Kimney, who is going to speak about urbanization, demographic transition, and the growth of cities in India, 80s, 70s, 2020. Shimne is Assistant Professor of the Department of Economics, Indian Institute of Management in Ahmedabad. He has worked in academic, corporate, and government institutions in India, UK, and Italy, and his research has been featured in journals, newspapers, and policy portals. He holds a master from the London School of Economics and a doctorate from the Indian Institute of Management of Bangalore. His research interests lie in migration study, urban economics, and business and economic history. So thank you very much to be here today. And so we'll let you do your presentation, and then, as usual, we will have a series of questions for our speaker.
All right. Thanks a lot to CSH CPR for organizing this workshop. Right. So thank you, CSH CPR, for this wonderful workshop. It's, I think, the 82nd. So I was telling them some sort of a record in terms of how many workshops one can have in a series. This is a paper funded by the IGC Research Network, International Growth Center, and it combines two of my research interests. One is in urban studies, urban economics, and the other is in business and economic history. And what I'm going to talk about today is very simple. It's about two questions. One is about India's urbanization. We hear in the newspapers words like rapid urbanization, India booming, cities booming, etc. So how do we make sense of this? And we'll see that India is urbanizing slowly, and we're going to try and understand why. The other question is why some cities seem to be growing faster than the others, and questions related to that. So the starting point for our presentation is just a quick comparison between India and China in terms of getting people away from the farm workforce. And if you see, this is each dot represents a country, and the trail out here represents China, the reds, and India, the blues. And so from about 1980, India has been able to take off, far few workers relative to its population off farms. And as a result, the urbanization, at least the official number, is about 31%. Whereas China has been able to pull out, starting from the similar position, has been able to pull out much more. One simple reason is economic growth rates have been higher. But economists have shown that for a reasonably large sample of countries, when you look at economic growth rates, for its level of economic growth rates, India's urbanization change has been actually very slow. So a puzzle remains. Second, there's a lot of talk about India's urban definition. As of now, all of you are aware that it includes municipal bodies as well as what are known as census towns, with a threefold criteria of population, density, and occupation. And so people say, look, India's urbanization is not 31%, it's 45%. The problem with that is that it doesn't change this argument of pace. So whether you look at the official definition, India's urbanization changed from 27 or 28 to 31 from 2001 to 2011. If you consider all the settlements in India which have more than 10,000 people, and say even they are urban, so let's not look at density or anything else, you can push up the number to 37%, and you can push up the number to 57% if you included settlements with more than 5,000 people, which is a definition used in many countries. 5,000 people settlement is classified as urban. 5,000 people in the population and 47%. Yeah, so 47. So as per this definition, India's urbanization rate is not 31% but 47%. But in 2001, as per the same definition, it would have been 40%. So this is almost some sort of for people who have studied economics, there's something called the Hindu rate of growth. This is almost like a Hindu rate of urbanization. 3 to 4 percentage points change per decade, and this has been happening for the last 40 years. And when you compare it with China, which has been having 8 to 9 percentage point change, that's a huge difference. So the question we ask is, why is India actually not rapidly urbanizing, which is very counter to what you read in the media, and why are some Indian cities growing faster than the others? Now, typically the literature on this has focused on migration. And one simple answer to this question is that there is no migration in India, or relatively low migration in India, and migration is not there because of restrictive caste networks. Now, having studied migration fair amount, I wrote my PhD in the history of migration. I know that there's a lot to the migration story, but the people are moving. It's not that people are not moving; they're moving. So we're going to look at migration in a bit. But the other part of the story, which researchers have not looked at, is the demographic transition. What we talk as fertility and mortality, which is surprising, and we'll see that that's a huge part of this story. The data we use for this project come from a variety of sources. One, we use the sample registration system Vital Statistics, which actually provides data for rural and urban. So you have birth rate, death rate separately for rural and urban at the state level. So this is nothing at city or district, just the states. Then we sort of put up a database fairly unique in the sense that it covers data from every census since 1872. So 1872, 1881 and so on till date on the population of major agglomeration. So how do we do that? We use two main sources apart from the old census reports themselves. A report compiled by Census Commissioner Mitra in 1980 had already done most of this work for the period 1872 to 1971. A census publication of 2001, published in 2008, table A3 or A4, actually provides the data in today's jurisdiction boundaries, and that's important. Okay, so you have Delhi urban agglomeration or Mumbai urban agglomeration in the boundaries of 2001, and they've worked backwards all the settlements in previous years. So it's a very neatly comparable database still then. We've updated that till 2011 broadly. It's not a perfect match. So we have about this huge database of about 350 odd urban agglomerations. If you look at census 2011, there are 468 urban agglomerations being defined in a particular way by the census. There's also some data on urban units provided by the census, which is not very accurate. So we are still working on this, but it provides data on more than the urban agglomerations. But these urban agglomerations cover more than 65% of India's urban. So even working with just 350 of these units is a very fairly large. It's very representative of urban India. We also look at districts in 2001, but also 1901 and 1961, and we use certain matching techniques to match data from 1901. There were much larger districts then till now, and some other indicators on railways and workforce details at the city level, etc. So what do we know about urbanization in India? One, this is a chart showing you over 110 years in terms of the census profile. India's urbanization starts from about 10% at the early 20th century and is today at about 31%. Now the definitions vary mainly in 1961, so there's one change out there, but the definition applies to all the parts of India, right? So you can compare across states fairly well. And so when we say Tamil Nadu has had much faster change of urbanization, we are saying it's a trebled from about 15% to almost 50%. Whereas in Bihar, it's been about 5% to 10%. So this is one way of seeing India's economic history. Today, there are about 8,000 towns with 380 million. So more people live in urban India than the entire population of the US. So that's a point to keep in mind when we talk of low urbanization. If you look at where India is urban today, this is just at the district level showing percentage of people living in urban areas. You'll see some distinct clusters which we are all fairly aware of. There's Coimbatore cluster here, there's a Bombay, Pune, Mumbai, Ahmedabad cluster here around Delhi, and there's fairly vacant spot. So the yellows are where it's less than 20% across central India in this part, some parts of eastern India and the Himalayan states. Now this is a chart again across 110 years which is showing you urbanization rate. Each line there depicts the urbanization of a state. Now I'm not labeling the states because it'll be very messy, but the idea is just to show that these lines rarely intersect, okay, except for this one jagged line here which is Kerala, which changed its urbanization due to reclassification in the past decade. But you'll see that basically what you're saying is that there's a very strong correlation between urbanization in 1901 and 2011. So 0.7 means about 50% of your interstate urbanization rates today is predicted by the starting point in 1901. So very, very strong persistence through time. So where you were in 1901, pretty much 50% of the variation of interstate urbanization is predicted by that alone. Again, trying to show that they're very strong one needs to understand the historical forces propelling this urbanization. We also know that India's in a way skipped the manufacturing revolution, and so most people who work in our cities are not in manufacturing, they're in services. This is just to show you that this is a district level distribution. About 80% of workers in urban areas work in the services sector. This is a district level distribution. What it's showing is that virtually no district in India has a dominant manufacturing sector. Surat is one exception, so you have a few plots here, but the bulk of India, the bulk of urban India across the board is in services sector. So there's a dominant manufacturing sector. The classic industrialization and urbanization linkage never really happened. One thing which is not well known enough in India is that we are aware that there are more males than women in many of our cities by a substantial margin, which is beyond the skewed child sex ratios because of migration. But it's actually quite unique. If you look at the world, this is each dot out here on the map is a country. Most countries have relatively more feminine urban sex ratios than rural sex ratios, which means that countries lie on top of the 45-degree line than below. And India is the red dot here, which is below. Right? So India is one of the few countries. The other countries are Middle Eastern countries where the urban sex ratios are more masculine than rural. Actually, the bulk of the world, it's the opposite. And this is not just because of one or two cities or places of India. This chart on the right shows you the same data comparing urban and rural sex ratio, but this is across Indian districts. So at the country level, most dots lie over the 45-degree line, and within India, most dots lie below the 40. And you'll see that there are points out here with extremely skewed urban sex ratios. We're calling this a process of masculine urbanization, which is a very important part of our migration story, which is that it's highly, highly male dominated, much more than it is especially in China. And finally, there's a very good relationship between urbanization and incomes across India. So this shows you the chart between urbanization and per capita income across states, so very high correlation, 0.9. But what's surprising is that it also holds with respect to income growth over the last 40 years. So for example, if you look at urbanization 1971, and you look at what happened in terms of per capita income growth over the next 40 years, you'll see that there's again a very strong relationship. The correlation is 0.2, which means relatively more urban states in 1971 experienced faster growth rates after time. So what we are saying is, in a way, regional inequality did increase to some extent. Now, these are some features which are fairly well known. So what we are contributing out here is to understand the demographic transition. This is in one chart trying to explain what has happened in India over 110 years. What happened was, till 1921, India suffered from famines, plague, the influenza epidemic of 1718, and then after 1921, you will see death rates plummet. So 1921 is a threshold year, after which death rates plummet. And birth rates take time to adjust to this new phenomenon, new world of relatively lower death rates. And so in this process, the population of India starts to grow naturally. That is the excess of births minus deaths. And this green line then starts declining in the 1980s or so. Right? So this inverted U shape is the demographic transition. That is, the population starts to grow as death rates collapse, and then birth rates start to collapse, so the population starts to stabilize. So today India is growing slightly at a slower pace than what it was in the past. Now, this has happened in a very interesting manner. If you look at the last 40 years, each line out here depicts a state. Across states, mortality rates have converged. Okay, so you had a huge variation in mortality rates even in 1970, but they've all converged. So there's very little difference in mortality rates across states today. The differences, though, are still in fertility. Okay, so fertility differences which were there in 1970 persist broadly through time. Okay, so this is important. Point number one, that is, if you want to understand the demographic transition, why it varies substantially in different paths, you have to understand fertility, not so much mortality. Now, one aspect of India's demographic difference has been well documented, the north-south divide. That is, we know that Kerala is in fact now an aging society. It's on the other end, so population is growing naturally very, very slowly, vis-a-vis Bihar. Huge amount of work done by demographers, economists on this north-south divide. What has not been documented is this, and this is in a way the key chart of this presentation. In the last 40 years, there has been a divergence between natural growth rates of rural and urban areas. This is basically saying at one level you had the demographic, so you're saying Kerala is growing slower than Bihar. What this is saying is that rural areas are growing faster than urban areas naturally, which means the excess of births minus deaths. What's important to note is that this difference was not there in the 1970s. This is a difference which opened out pretty much from the 1980s, and it has expanded through time. Right? So you can clearly see this. So this is what we're calling as a demographic divergence, and this is very, very key, because what this means is that the green line being top on the red line, it means that villages are growing faster than towns in the absence of migration and reclassification effects. This has not been documented in many other countries, and you'll see that it was not the case in India until this point. So we're going to try and understand this phenomenon better. You might think this is obvious in the sense that birth rates are higher in rural areas, but what matters is the natural growth, because it is almost always the case in India that birth rates are higher in rural areas than urban areas, but death rates are also higher in rural areas than urban areas. So what matters is the difference, the natural growth rate. What is even more remarkable is that this thing did not happen all over India. It did not, for example, happen in the South India. Right? So if you look at South India, you'll see that these lines track each other very nicely. Okay, so natural growth rates fell, but they fell in the same way for both rural and urban India. So South India did not experience this demographic divergence. What we're saying is that villages in the south grew pretty much at the same rate as cities in the south, naturally speaking, that is the excess of birth minus. So what is driving the all India figure? So we look at each state. We don't find much evidence in Maharashtra, we don't find it in Haryana, we don't find it in Punjab. We find it in what is traditionally been known as the Bimaru, or the northern hinterland states. So if you look at these states, Rajasthan, UP, Bihar, Assam, West Bengal, Madhya Pradesh, this is where the divergence happens. Okay, so these are the places where rural areas have grown naturally much faster than urban areas. So this is not a pan-Indian phenomenon, but because these states have a huge demographic weight in India's overall population, it affects the all India average. Now West Bengal is interesting in the sense that there's no divergence, there's been always a huge difference. And that's because a huge part of urban West Bengal is Kolkata, and Kolkata is historically had very, very low fertility rates across Indian cities. Yeah.
Do you have a data point for West Bengal in the 1970 to 80?
For some reason, yeah, the census does not provide it. It's a good observation. Yeah, it doesn't. Now, the simple meaning of this is that you have slower all India urbanization and you have greater regional variation. Right? So what this means is you don't need migration, you don't need reclassification as an explanation for varying urban patterns. Just the varying demographic transitions, why fertility or why natural growth rates are moving in a particular way, is actually telling you a lot about north-south differences in urbanization. What this is telling you is, suppose you have the same migration rates, village to city, in the south and north, South India will still urbanize much faster than the north, because for every person coming to the city, there are more people being added to the villages in the north. Right? So this is one classic sort of feature which we document in the urbanization as well. So we look at this now at the district level. So the data earlier was of the SRS, which comes sample registration system. We now look at census data. We first look at national growth rates and we try and see what is driving this difference. Is it fertility, mortality? We note that it's fertility differences. So it's basically the fertility rates in village northern India which haven't crashed as dramatically as they have in South India. So we plot this. This is using a different data set which is giving us the same story as the SRS. So it's a good external validity. So for example, you could argue that this data is wrong, but now this data is coming from a different data source and it's showing you precisely the same thing. That is, in those regions, in these regions you have high level of rural-urban differences in fertility, whereas in the south you don't see that. Okay, so you have pockets in the south, parts out here, parts in Orissa and so on, but these are the blue regions are where it's very high. Okay, so that is where the rural-urban differences in fertility seem to be very stark. So what explains this? One possible indicator, so one major determinant of fertility is of course human capital in terms of education. So we look at that. The other thing, of course, this chart looks very close to India's map on agricultural productivity. because you'll see that agricultural productivity in these places are relatively lower. For example, in Haryana, Punjab, and these regions have much higher. So why should agricultural productivity matter? We think it matters because there's an income effect on fertility. The richer you are, the fewer kids you have. So we do a simple regression analysis of this variable of rural-urban fertility differences, and we regress it on yields and literacy rates. There's not much of an intersection between these two variables, and you'll see that this sort of model 2 explains about 60% of the variation, even after you control for state level variables. What this is saying, if you don't like numbers, just read this on the left. It's saying that regions with higher agricultural yields have lower rural fertility and hence lower rural-urban difference. So other things being, what this is saying is that if you boost agricultural productivity, historically in the classic sort of Lewisian case, it releases labor to go to cities. So that is one channel, that's the migration channel. But what we are documenting is a fertility channel. That is, you're having fewer kids in villages, and hence the overall region is actually urbanizing faster. We then do a simple simulation test. So we say, suppose India's demographic divergence did not exist in 2001, just in 1 year, India's urbanization rate would be 4 percentage points higher. So it would not be 31, it would be 35. That is just for 1 decade. So if you can see the cumulative impact over the 3 decades, what we are saying is that this one factor, this differential demographic transition, explains a huge part of the story. We are saying about on over 50% of the story of slow urbanization in India. What it's also saying is that agricultural productivity, ironically, people don't consider, they consider 2 different words, but rapid surges in agricultural productivity are likely to lead to faster urbanizations, urbanization being the share of urban population and total population, through the channel of lower fertility in rural areas. So that was on urbanization, trying to understand this puzzle of slow urbanization. And again, the argument so far has been on migration, and so we look at migration in a bit. But what we are arguing is that the big story out here is the demographic transition. And now what we find is that the demographic transition matters not just for urbanization, but also for urban growth. So we're going to try and understand fertility across Indian cities. This is one quick chart by Bhagat, Professor R.B. Bhagat at IIPS, which looks at the contributions to urban growth. Just splitting it between natural increase, that is births minus. So if you look at Delhi, how does the population of Delhi grow? Or in any region, you have to have your births, you have deaths, and you have migration. But migration 2 types, there are people coming in and people going out. So what matters is the net migration. And then you have the reclassification of Delhi itself growing a bit larger. So all these things add to Delhi's urban growth. So what this chart does is to break this up at the all India level, and you'll find that it's roughly a 50-50 split. Natural increase contributes to 50%, and migration and reclassification contributes to the rest. But you'll see this black line, which is natural increase. It rises from the 1970s, 80s, and then starts falling. Right? Very much in tune with the demographic transition. So as now fertility rates are falling, even in Indian cities, you'll find that the contribution of natural increase is going to fall. And in my view, it's going to fall from every decade from now. Okay. So even with no change in migration patterns, you're going to see lesser and lesser, you're going to see more contribution of migration to urban growth, purely because fertility is falling on the other side. I'm going to just skip this chart for now. This is just looking at densities across class sizes. What it basically shows you is that larger cities in India have much higher densities. Okay, so I'll come to city growth rates. So we want to understand the distribution of city growth rates over time. What this chart, so this is using the database now from 1870s to now. And we are breaking it through time periods. The x-axis is annual growth rate. Okay, so for example, this chart out here, the green distribution, what it says is that this is the distribution of 300 odd cities of India, which contribute to more than 65% of India's urban population. And the average growth rate of the city between 1881 and 1921, average annual growth rate was 0. So cities are not growing. Right? So 50% of the cities experience positive growth rates, 50% experience negative. And this is a period of epidemics. This is a period of the famous Bombay plague of the late 19th century. This is a period of a lot of crisis. This is also a period of the railways and a lot of migration to cities. But what's interesting is that in this period, the average city of India actually did not grow. Right? and it starts growing only as the demographic transition kicks in, which is after 1921. Okay, so you'll see that the distribution shifts right, which means virtually every city now is growing faster in this other period. And so in this period, there are very, very few cities experiencing below zero growth rates. So now virtually every city of India is growing at some level. So growth rates rose in the early 20th century as death rates plunged. What happens next? So we look at the period 1951 to 1991, and the curve shifts right again. So city growth rates shift to the right, which means that now the cities of this period are growing faster than the cities of this period. And now in this period, virtually no city of India between 1951 and 1991 experienced population decline. Right? So all of us in a way belong to a generation of people who have seen cities only grow in size. Whereas if you were born in 1861, it was not very natural. Most cities actually did not grow. So it's a very different feel of the city versus what was there a century ago. So growth rates rose further. Now what's interesting is what happens in the last 20 years. Okay, so we hear of booming cities, etc. But this distribution actually shifts back to the left. The average city of India today is growing slower than it was until 1991. Right? So this is that chart, and you'll see that now the red line is sort of shifted back to this. Okay, and you'll see that there are some cities of India which have actually had declining populations. Okay, some of it is because of area reclassification, but there are some towns which actually had negative population growth. There are some wards in major cities which have, like Calcutta has wards which have had declining population growth rates. So very different urban world we're talking of. So this is what has happened. Of course, there are obviously exceptions, and this distribution tells you the exceptions, right? Because we are saying the average has shifted, the entire distribution has shifted, but there are obviously many cities in this end of the range as well. What this sort of distribution gives is, imagine rows of cities with their growth rates, and you're just plotting a distribution. So this is the average, but you're going to have some cities of India growing at 5%, 10% per annum. Yeah.
These are all cities of today, and going back, the areas that they once represented.
It is in the areas today.
Yeah. So what is urban today?
Yeah.
Which in 1881 was rural.
Yeah, I mean, if that settlement...
So you're benchmarking it. I just want to know where you're benchmarking it. 2011 census?
2001.
Census.
Yeah, the boundaries of 2001. Yeah. Right? And so some exceptions. For example, if you look at the major cities, the top 20, 30. So Surat and Tirupur have been growing at about 5% per annum. So just to give a ballpark of what these numbers mean, India's population is now growing at 1.6% per annum. Okay, so that is India's overall population growth rate. So if a city is growing at 5% per annum, that is explosion. That is a huge amount of inflow. I think Delhi is about 3 to 4%. Of course, now Delhi has a particular issue of being defined within NCT, and you have Faridabad and Noida, which are outside the built-up space, etc. But we also look at built-up space around cities, redo the analysis, it doesn't change much. So for certain places where there are certain definitional issues, we just change the boundaries, look at it once, and it doesn't change the overall analysis. But Surat and Tirupur are interesting because they're both textile cities in some ways, and then both had phenomenal growth. In fact, they've had faster growth in the last 20 years than earlier. Yeah.
That explains any proportionate growth, corresponding growth in the textile sector?
It's a good question. So there has been, of course, a lot of growth in the textile sector, but it's been mixed, because textile, these two cities have grown, but Ahmedabad has fallen and Bombay has fallen. So in a way, it's the move from the composite mill to power looms, and that is also happening. So it's a way. Yeah, I mean it's industrial diversification in some way. So I mean textile has been an important part of urban growth for Bombay in the early 20th century, or jute for Calcutta in the early 20th century, and so on. So this is just to put all the charts together. Right. Now that doesn't give you a sense of one question, are the larger city growing faster than the smaller cities, and how do you do such an analysis? So these are some indicators to show if city size distributions are becoming more even over time. The top number, again, it's a geographic economics term called the Zipf's law coefficient, but broadly if it's going up, it means that it's evening out. Okay, and these are shares of primacy. So for example, the red line is the percentage of the largest city's population as a share of the largest 5, or the blue line out here is the top 5 cities' population as a share of the top 50's population. So these are different measures used by geographers to measure city size distribution. And what you find that across these measures, between 1881 and now, you find broadly a more evening out of the distribution. In the colonial period, and this starts from the colonial period itself, but you'll see how, during the colonial period, it is much, much more concentrated. Okay, so we know from the economic history literature that it's concentrated around Bombay, Calcutta, and Chennai, and Madras. But over time, even it starts from the colonial period, the distribution changes. And this distribution changes faster and faster. In fact, in the last decade, there's not been much of a change, in fact, a slight decline. But broadly, there has been a growth of intermediate cities in India. Now, one criticism of this is just the data itself, because we're looking at the large cities of 2001. So, by definition, we are taking the fastest growing cities over the century. So, we take sub-samples out of this analysis. Instead of looking at all 350 urban agglomerations, we look at the 100 urban agglomerations which were the largest urban agglomerations in 1901, and then we redo the analysis. It's the same. Okay, so broadly this is a very important. Now this is a picture of 1901. Now this is obviously not how India looked in 1901. This is just overlaying city populations in 1901 on a current day map. So we have, for example, Kolkata as the largest city of India in 1901 with about a million people, and then you have, so this is India in 1901, which is the colonial city, the port cities through which the colonial empire is working, and then you have Hyderabad, which is fairly big, and Delhi is nowhere on the map, correct? In 1901, and you have certain clusters in the south, which is relatively more evenly spread, Madurai, Coimbatore, etc. And then you have Ahmedabad, Surat. Surat, of course, at one point was the largest city of India in the 17th century. But broadly, there's a distribution. But you'll see that this space out here has very few major cities, major as per a certain definition of more than 100,000 people. Right, so what happens today? So we're going to show a map of 2011. So this is what it sees today. Now unfortunately the colors are very light, so you can't really see. But if you see the big spots on the map, so you'll see that obviously Delhi has popped up on the map. Right? So Delhi is nowhere in 1901, and today it's suddenly a huge part of the map. So you have one triangle here, out here, and then you have this another triangle here between Hyderabad, Bombay, and Chennai, which is non-existent. In fact, Mysore and Bangalore, there's not much of a difference in 1901. So one part of the story, we want to understand what is driving these changes. Why have some cities grown faster than the others? One part of the story comes from that city size distribution. So intermediate cities have grown faster, and there's a particular literature in urban economics which looks at market size and why this is happening. But it's also a tough question to answer because the data for this is not really available from all these time periods. So we're going to look at it in two ways. For the overall sample period, we just look at very simple variables like political headquarters, are they growing faster, etc. But we're going to look more closely at the current day. Okay, we're going to look more closely at the last 10 years, for which we have data on fertility, migration, and we're going to try and understand that much closer. Right, so this is just a chart which shows you variation of growth rates across time, but two important things are the capital city and initial British rule. So if a city was directly ruled by the British, it had much higher, because you had directly and indirectly ruled places. So Mysore is indirectly ruled by the British. It's a princely state and so on. So basically political centralization as a major driver of urban growth over the last 100 years it's a very important variable which comes out throughout the sample. The work on growth in Indian cities broadly out, there has been some work on particular census periods, etc. Two important works, Mills and Becker in 1986 and Kala-Sridhar in 2010. And Kala-Sridhar looks at the period 1991 to 2001 using census data. And both of them highlight the significance of agglomeration. That is, if you are located to a larger city, the town is likely to experience faster growth. So that's one hypothesis that we're going to test, and we find that it's a very, very strong predictor of urban growth in India. But we are actually going to dissect it again through the lens of demographic transition. And this is something which neither of these studies did, to look at fertility itself. I think the assumption has always been that fertility has broadly been similar across cities. But what we'll see is that there are huge differences in fertility across cities. So this is a simple schematic we developed to understand city growth in India. Cities can be classified as either high fertility, low fertility, or high migration, low migration. Now, high migration, so if city is having high fertility and low migration, it will be growing internally. So not many people coming from outside, but high fertility driving the city growth. Similarly, you'll have external growth if it's just migration, and a city out here will be explosion and stagnation. Now, the literature on fertility, of course, a lot of important variables out there, but human capital being one of the most important. The more educated you are, the fewer kids you have. In migration, of course, economic opportunities, but what kind of economic opportunities? So we're going to look at sectors which have driven this growth. We look at gender being a major part in India because a lot of this migration is male dominated in nature. And networks matter hugely in migration. So much of my work has been on migration, has been to understand these migration networks. But what I'm going to do is you can see the schematic, and I'm going to overlay data on this. Okay, so you're going to see a chart with fertility on the y-axis, migration on the x-axis, and each dot on the map is going to represent a city. And it looks something like this. So this is data of fertility index. It's a child-woman ratio at the city level. And this is the migrant to population ratio in 2001. Unfortunately, the census of 2011 has not yet released the migration data. So we still don't know the most recent migration data. So this is just using that. But what's interesting is that there's virtually no relationship between fertility and migration. This is a nice circle. You'll see that it's virtually no relationship, right? But if you look at the schematic, this is what is happening. Cities of India are growing for different reasons. Okay. Now I'm going to give you 4 examples. Kolkata. Okay. It grew between 2001 and 2011. So the number out here, 0.7%, is the annual growth rate in the past decade. That is 2001 to 2011. So it's growing very slowly because there's very little migration and there's very little fertility. You have a city like Bhubaneswar growing at 3%, a lot of migration, but not so much fertility.
How is that fertility index configured?
Yeah, so it's a child woman. So good question. So fertility in India, unfortunately, we don't have very good. You don't have TFR or total fertility rates at the city level. So the way we construct this is as follows. Demographers use something as a child-woman ratio. So typically that is 0 to 9 age grouped children divided by 15 to 44 aged women. And that correlates extremely well with the standard measure of fertility, which is total fertility rate. So we use age group distributions. So you can use 0 to 9 on 15 to 44. You can use 0 to 6 on 6 plus. There's virtually no difference in that. Because the age groups, if you use the age group ratio, it's very stable across age groups. So we use a particular age group ratio out here to define. What we then do is we compute these age group ratios at the state level to match it with the NFHS data on fertility. There's a correlation of about 0.9. So we are very confident that this is a good measure on fertility. The NFHS 3 also has TFR rates for 8 cities of India. It lines up perfectly across that. So of 8 cities, not much of a sample, but that's the only good fertility data that I know of at the city level. And this fertility index matches that. So in that sample also, Kolkata has the lowest fertility. Right? So Surat is a case where you have relatively high fertility and migration. Okay? And then you have a town or city like Sambhal in UP, which is growing at 2%, okay? Which is above India's 1.6% growth, but there's no migration, but just on account of fertility. Right? So clearly different cities growing for a combination of these reasons. To this you can add reclassification, but reclassification happens, it happens sporadically, once in typically 30, 40 years, or it depends on which city you're talking about. So we're not looking at reclassification, and I've chosen these particular cities because there was not much reclassification among them. Okay, this is just to give you an idea of 2 ways of looking at urban growth. And now we're talking of urban growth because if you're talking of urbanization, you need to be talking of rural growth as well. So right now we're just talking of urban growth. So we try and understand these components. So this is a simple we're trying to understand why some cities grew faster in the last 10 years, and we regress this variable on standard indicators, that is migration, fertility, just to see if we get the expected signs, expected things. And we find that about 60% of the model can be explained through the standard variables, that is fertility, migration, agglomeration. In the West, a huge part of the literature on city growth has been on human capital. So there, what they have been arguing is that with human capital accumulation, the productivity benefits, and that's why people come to work in those cities. So human capital accumulation drives city growth. Now what's interesting is that this literature developed in the West at a point when fertility rates were very low. So they were studying city growth without the demographic transition because they were already at the end of the demographic transition. Whereas you can't do that in the Indian case. So for example, out here, there's very little difference in fertility in say across a sample of American cities, whereas in India it's substantial. Okay, so we find that this basic model. So what we're going to do now is to look at fertility and migration separately. Yeah.
Could you explain the dummy variables at the bottom?
This one. So we look at, so these are some geographic dummy variables. So coastal cities, if the city is located along a coast, river, if there's a major river which flows through the city. These are geographic variables. For example, if it's a hilly region, you could expect some sort of a constraint on city growth, how much it can grow, like a physical constraint sort of.
And on the other hand, coastal cities and rivers and capitals are have increased.
It could have, yeah. I mean, that's the rationale for this thing. This variable is the agglomeration variable. Okay, so you see what this negative sign means, and you see that these numbers nicely rise with size. Basically, if you're a city within the radius of so imagine there's Delhi and imagine there's a town within 100 kilometers of Delhi. As you go 100 kilometers further, city growth rates fall. And as you go even further, city growth rates fall. Now, of course, you look at India's map, you can't take just Delhi as one point. So I've taken the top 8 cities because their top 8 are fairly large. They're 5 million plus. So imagine a town which is more than 500 kilometers, it straight away has less than 2% growth rate. So what agglomeration does is basically it's picking up for city size effects or the market size effects. So the closer you are to a big city, there's more connection, there's more economic connection between the big city, and hence you sort of growing at a faster rate. Again, growing not because of fertility, but because of migration. Now what's interesting here is to think of how human capital might affect this. Right? Because what in the West the literature is saying, human capital drives migration. So we're going to see if that works for India. And we find it does. But we'd also know that human capital has a negative effect on fertility. Right? So there are these two contrasting effects. And so if you actually put human capital in this framework, just saying does human capital drive city growth rates, we find that there's no relationship. But it has a very strong relationship on both the features. It has a very strong relationship on migration. It has a very strong relationship on fertility. So we try and separate out those two effects. So this is fertility and literacy. Okay, and you have this beautiful sort of negative correlation. So, and what's interesting is this is just a very crude proxy of education. We've tried various things, but because literacy rate is widely used, we use this. Once most cities are literate, then you have to start using percentage of population in higher education or more refined educational measures. But we are at a time where this is the variation across cities. It's between 50 and 100. So that's substantial variation. And you have substantial variation in what is the fertility index as well. Okay. So there is massive variation in human capital across Indian cities. And this matters because what this means is that you don't, if a city is very highly educated, if it has a highly educated workforce, you're also going to have fewer kids in that city. So the internal growth to some extent will be muted. Vis-a-vis a small town of India where nobody's really going to, and there's not much of human capital, but there are a lot of kids being born there precisely because there's lack of human capital. So there's a huge fertility effect out there. And so that city could be growing even faster. Now this is what we think is the explanation for India's city size evening out over time. Because we know that larger cities in India have more concentrations of human capital, whereas the smaller towns have less. And so because they have less, they also have higher fertility, which means they're growing at a faster rate than the larger cities. You have a question? No. We then map out fertility across cities of India. So this is using that fertility index, and you'll see that the heat map basically shows the broad north-south divide that we know at the state level. So for example, these towns out here have this shade of less than 0.2, but it's almost half of towns out here. So very crudely put, cities or towns of the south are growing much, much slower than the average town and city in the north, purely on account of fertility. Right? And what is driving fertility is human capital, at least in this framework. What we're saying, so this is interesting because urban growth, this is urban growth, city growth. Urban growth, if you ignore for a minute migration, is now higher in the north than the south. Whereas what we saw in the earlier chart was something very different, that urbanization was slower in the northern hinterland than the south. Right? So this is an urban paradox of some sort. That is, in the north, the towns are growing faster than the towns in the south. But because in the north, the villages are growing even faster, they're not urbanizing in the sense that the share of urban in the overall population is not changing drastically. Now I'll talk of migration. How many minutes do I have? Yeah. Okay, perfect. Yeah. Now, much of my work has been trying to understand migration, and what I find, at least in the NSS data, in a lot of my fieldwork, of course, my fieldwork has been in places which had these kind of migration, mainly Surat, but you find migration for work in many large cities, especially, to be heavily male-dominated in nature. Right. So, in the NSS workforce, if you look at work-related migration in a very careful manner, there's work by CWDS recently on this. About 80% of migrant workers are male. Right? Now, if you look at just the migration statistics, virtually every adult woman in India is a migrant because of village exogamy and marriage. But if you took a migrant worker, especially with some sort of a distance-based migration, it's overwhelmingly male-dominated. It's semi-permanent and not seasonal, and that's also a distinction. There's a lot of seasonal migration in India. People coming for 2-3 months of a city, construction work, agriculture work also. But this is semi-permanent. So this is the classic huge informal sector that you see in Delhi. The people working in restaurants and the cabs. Security guard is a huge industry employing such labor, where these people are not likely to settle in the city. Okay, and they're also going to go back. And it's led to this huge flow of remittances from cities. So the source regions have also become remittance economies. Now, what is the implication of this, of what we're calling as remittance urbanism? That is a way of life where you're sending back money all the time. Is that there's actually slower net rural urban migration, which is another pressure on slower urbanization. That is, it's not the case that nobody is moving. They're moving, but they're also moving back. And they could be moving back not just after 1 or 2 years. They could be spending their entire life here and then eventually retiring back. And that's a very important phenomenon. And so you have younger cohorts of people coming in, but they're not adding substantially to the city because they're being replaced by older cohorts going out. Okay? So there's a difference between gross flows and net flows. This is one example of showing you how persistent mass migration has been. Yeah.
Just with short-term migration, given that this is sort of a long-term process, right, over a lifetime, it's only after that people move back. How significant is it in terms of considering people? Do you not consider people migrants for that entire period that they're away, which might be longer than the initial period they've been in the village in the first place?
Correct. So, there's a very standard definition of migration. So, people are following that. There's a last place of residence. So, it doesn't matter if you're 10 years or 15 years. If you have moved, you classify yourself as a migrant. So, that is the case. A lot of my work on migration, I was talking in the morning, has been on using data on out migration. If you look at the census, there are no migrants in India because they ask you a question, are you a migrant? Whereas the NSS also has a question saying, do you have members of your household who have gone away? And that gives you a much more powerful statistic on migration. So a lot of these migrations. So for example, this chart. This is showing you sex ratio across every decade. India, we know, has a sex ratio about 950. There are districts in India, what I call as missing men phenomenon, not the missing women. These districts, Ratnagiri, it has never had a sex ratio of less than 1100. This chart shows you 110 years, but the data actually extends from 1872. This is a story of persistent male migration across over 5 generations. Right? And in the case of migration and Udupi, the major destination is Bombay, but of course now also the Gulf and other parts of India. Right? This is just a photo, just to give a sort of personal side of the story. I'm doing some fieldwork in Ratnagiri district, trying to capture these migration histories. And here's a family which has migrated to Bombay. All the male members have worked in Bombay, but none of them are going to settle there. Right? So it's a phenomenon. And incidentally, this photo was taken in Bombay, and so you have women in the photograph, and they'd gone to Bombay precisely to take the photograph in the 1960s. So that was one of the reasons. This was taken in Chembur. Yeah. This is the city of Surat. It's a remittance visiting card of a remittance operator, which shows you just how clustered the migration networks are. This is a guy who sends money only to particular districts like Azamgarh, Mau, Jille, and so on. Right? And so you have this huge economy of remittance-based operators who work in cities in India. This is urbanization. This is where people are moving from in India. This is based from the NSS. This is published work. You'll see that you have this huge Eastern UP cluster, but it's not just that. You have the entire west coast stretching from Kerala to Ratnagiri. You have a Rajasthan cluster. You have a coastal Orissa cluster. You have the Himalayan cluster. Right? I've discussed in separate places as to what explains these migration patterns. These are source regions of migrants. Where are people moving from? This is dated. It's 1990s data. But to Mumbai, people are moving from everywhere. From Delhi, mainly in the Gangetic heartland. But again, this is data from the 1990s. But again, to show you how strong the networks are. You have particular districts of India sending huge number of migrants. For example, you'll have more people sending migrants from Eastern UP than a district very, very close by. So we find that for migration, human capital matters, and also the nature of jobs. We find that IT and government jobs, two things matter a lot to explain city growth variation between 2001 and 2011. Now we think of IT, we just think of Bangalore or Hyderabad or Pune, but actually this data has for all the cities. So it starts from, I think the maximum is about 5% of the workforce, I think in Hyderabad or Bangalore. In 2001, again this is dated, so it's not very recent, but there's variation across the city gradient. And wherever you had relatively more IT investment, you saw faster, presumably economic growth linked with migration. But interestingly, government jobs, public administration, a particular code in this workforce data, drawing in a huge number of migrants. I'm going to skip this. This is just again to show you how skewed some of the sex ratios of our cities are. This is again showing you over a 100-year period. Starts in the early 20th century. It's practically male towns. There are practically no women in Mumbai and Kolkata. And it rises over time. But even today, it's way below 900. Right? So this is a way of looking at migration which is very different. The key out here is gender. That is, one has to understand why is it so male dominated. So broadly, I'll just conclude. First, to understand anything on urbanization in India or urban growth, I think one big variable which researchers have not looked at in close detail has been the demographic transition. And so we've tried to do that. We argue that there's been a demographic divergence in India over the last 4 decades especially. This has happened not in the south, but in particular states, so particular districts. One important factor seems to be agricultural yields. Could be that relatively stagnant agricultural yields in these parts have not led to income effects on fertility, which has happened in other states. But however, there's higher urban growth in the north, precisely because of relatively lower levels of human capital and higher levels of fertility. There is also what we call as remittance urbanism, a kind of migration, which means there's very, very large gross migration flows, but very limited net migration flows. Again, a potential factor for India's relatively slow urbanization. And finally, we look at growth rates of cities. We find that human capital is a very, very important part of the story. But if you just ask me a question, does education drive city growth rates? The answer is no, because there's no clear relationship. But education matters for two completely different reasons. With a more educated workforce, you have reduced fertility and hence reduced city growth. But with more education, you also have relatively more productive, economic growth rates are potentially higher, drawing in more migrants. So there are two contrasting effects of human capital accumulation on city growth in India.
Capital city is what? Government jobs?
Yeah, so that is political centralization. We can call it that. So
Not the government jobs.
that is actually, yeah, you're right. So that should have been an added thing. IT and public administration are two additional variables out there. And so so this is what is the urban paradox. That is, you have faster urban growth in the north, but slow urbanization. And this has implications on, of course, in some way, public finances, because, these towns and cities in the north are growing now much, much faster, which means if you want to invest in housing stock, if you want to invest in infrastructure, there's some, I think, clear implications of this particular kind of research. There's some further work which we're planning to do. We're also looking at the effect of road expansion, but it's very tough to get data on road maps historically. And so if anybody knows of good road maps before 1950, I would be delighted. Thank you.